All right, so so these if the actual creatures that are the coral um, are really tiny creatures, but what they do is they secrete um, calcium carbonate. I was mentioning that in the last video, and they grow, and we can actually see that. That's the coral reef that we're talking about. Um, now, coral reefs and algae have a what's called a symbiotic relationship. The algae uh, gets protection from predators by living around the coral reefs. They have places to hide, and what the coral reefs do, the coral in the coral reefs, which are tiny little creatures, they rely on the photosynthesis that's going on with the algae, and also the fact that the algae bring this photosynthesis. Uh, they also bring nutrients to the coral reef, and so the algae and the coral live in a symbiotic relationship that's mutually beneficial to both. All right. And then over time, corals will die. That's a natural process that happens, but that there are certain pollutions and things like that which are causing coral reefs to decrease much more rapidly than they have in the past. And when we notice like the coral dying, it starts to lose its color, and that's called coral bleaching. And what's happening is the so one of the things that leads to this coral bleaching is and why this is a indicator of global warming is the coral live in relatively shallow depths in the oceans, and when the water gets too hot, then and stays that way, not just a single day or something like that, but the average temperature over the course of years gets too hot. What happens is the algae will leave the coral, or the coral will cause the algae to, well, basically, one way or the other, the algae leave, and then the coral starts to lose that nutrition and the photosynthesis that's going on with the algae, and it begins to bleach. This, losing its color. The coral loses its color, and we've looked at that as a good indicator of global warming. All right, so that's just another one of the many indications that we have that global warming is taking place. All right, so there are other factors outside of the Earth, actually, that go into the changing tides. You've probably heard of the tides before. If you've ever visited the ocean, you certainly know about them. And people who live near the shore, humans who've lived near the shore for millennia, have often noticed the fact that the tides and the moon, where the moon is in the sky, are related to each other, and indeed they are. All right, so let's go into that. So the cause of the tides, it has to do with what's called nobody knew that, but before Isaac Newton came along, nobody knew that. They just noticed that the moon, where the moon was, and whether it was high tide or low tide, depending on where the moon was, they noticed that there was a relationship. But Isaac Newton showed why that is, and so it has to do with the proximity, the distance between the Earth and the Moon is actually really, really close. They're in terms of miles, they're about a quarter of a million miles away. So 384,000 miles, 384,000 kilometers between the center of the Earth and the center of the moon. And so that really close proximity causes the gravitation of the moon to be, so the moon is pulling on the Earth, just like the Earth is pulling on the moon gravitationally. But what it does, because they're so close, the moon pulls a little harder on one side of the Earth than it does on the other side. And so that side of the Earth bulges towards the moon, right? Just due to gravitation. So of course, there's two high tides a day. So you might wonder, where's this other tide? Why isn't this a low tide over here, right? What happens? It's just like let me try to explain it. If you had a bucket full of water, right? If you just simply turn the bucket full of water over and didn't do anything, it would just, it would spill out onto the floor or wherever, onto the ground. But if you took the bucket and you whirled it around fast enough, you would reach a speed where the water would not go anywhere. And that's what's called the centrifugal force. And so what happens is that the water on the opposite side of the Earth, the opposite side of where the moon is, will pile up. And so that there's actually two bulges. There's a bulge that is in the direction of the moon, and there's a bulge 180 degrees away from that. All right, and now so let's get a little bit further into this. Let's see. Do they have? So now here's the thing. Let's go back to the picture. The moon is, of course, orbiting the Earth, so that you'd think that the high tides, you go to the shore or something like that, and you notice that there's a high tide, at 9 o'clock in the morning. You went for a nice walk along the shore, and it's high tide. And you go the next morning, you're on vacation or something like that, and the next morning you get up and it's 9 o'clock again, and you're like, oh, I'm gonna go out there and walk along the shore. And you notice that it isn't quite high tide yet, right? It actually comes about a half an hour later than it was the day before. And the reason for that is that the moon orbits the Earth, and it has moved by about 50 minutes, right? And so high tide to high tide is not 12 hours. It's more like 12 and a half hours. It's not even 12 and a half, by the way, because the moon moves once a day. It moves by about 50 minutes. So it doesn't exactly fall on the hour, but it's it's relatively close, or the half hour, mind you. So there are two high tides a day, and there are two low tides, and so basically your location on the Earth, you rotate into the high tide, and then you 6 hours later, about 6 hours later, you rotate into the low tide, and then you rotate into the high tide again, and then you rotate into the low tide, right? So, but of course the tides are, it's changing with the position of the moon, right? Because the moon is changing positions each day by about 50 minutes, right? So, so the moon moves around the Earth. The times of the tide vary each day by about 50 minutes, and so I mentioned that the moon pulls on the Earth a little stronger on one side, but it turns out that the sun does the same thing. All right, so now the sun, because the sun is so much further away, I mean, it's very, very massive. It's way more massive than the moon. But because the sun is so much further away, it has less than half the effect on the tidal bulge, right? So it's mostly the moon, and then to less than half as much, the sun has an effect. So in other words, if our moon wasn't there, the sun would definitely have an effect on there would be still be a high tide and low tide, just because of the sun. But because the moon is there as well, and there are certain times when the moon and the earth and the sun line up, just like this position here, right? So it doesn't matter whether the moon is on this, between the earth and the sun, or on the opposite side of the earth compared to the sun, as long as they line up, then you have what's called a spring tide. All right. So spring tides, you get the highest high tides and the lowest low tides. That's what a spring tide is. And let's, if you think about this in terms of, some chapters that we're going to get into a little bit later when we get to the astronomy stuff, and you might have done a little bit of this with your project. So when the moon is in the same direction as the sun, we call that a new moon. When the moon is in the opposite side of the sun, so when the sun sets and the moon rises, that is, the moon and the sun are 180 degrees apart. This side over here, when the moon's over here, that's called a full moon. So the only times that you're going to have a spring tide is during a new moon or a full moon, right? So that, and of course, the spring tides will only occur roughly twice a month. And then what about when the moon and the earth and the sun are at 90 degrees with respect to each other? So right here, the moon, the earth, and the sun are at 90 degrees. And so the tidal effect that the sun is causing, remember, it's not quite as great as what the moon does, but that is canceling out some of what the moon is doing, right? Because they're at 90 degrees. And so those tides are called neap tides, right? And so let's go back to spring tides, right? Spring tides, you get the highest high tides and the lowest low tides, right? So sometimes I gotta think about this. Okay, so with a neap tide, you're getting the lowest high tide, right? So it's because you're still getting a high tide, but it's being canceled out a little bit. So the high tide, it's the lowest high tide, and the lowest high tide and the lowest high tide and the highest low tide, right? So they're not as extreme when the moon, the earth, and the sun are at right angles to each other. And so this only happens twice a month. And so these are, of course, when you have the first quarter or the last quarter, or sometimes the last quarter is also known as the third quarter. So first quarter moon and last quarter moon, right? So first quarter moon is, of course, when the sun is set and the moon is at 90 degrees. It's the highest in the sky that it's going to get. And then the last quarter is, of course, that's the one that you see in the morning. If you ever see the moon in the morning, that's when the sun has risen and the moon is as high in the sky as it's going to get. So those are called neap tides. Twice a month those happen. All right, so let's get into the atmosphere, the composition of the atmosphere. So, at the beginning at the beginning of this chapter, we talked about how the Earth originally had a hydrogen and helium atmosphere, but that got blown off into space once the sun started fusing hydrogen into helium. And then the volcanoes created, there was lots of carbon dioxide. So notice there's the carbon dioxide right there, and water vapor coming out of the volcanoes. And these two made most of the atmosphere in the very early days, and then ozone and oxygen, of course, were created by the cyanobacteria.